Welcome to the deep dive. So you want to move past just using large language models and actually start building something truly sophisticated, an autonomous AI agent.
Mm-hmm.
Today we're tackling something that developers, even strategists, they rarely explain clearly. We're talking about the full 8-step blueprint for taking a digital tool from just a piece of code to a dynamic, intelligent entity.
That's exactly right. And we have a pretty definitive roadmap here. It defines what it takes to create a functional and, just as importantly, a reliable AI agent.
Okay.
Our mission for you, the listener, is really to unpack the why, the strategic trade-offs, the technical complexity behind each of these steps.
Right.
We want to move way beyond just reading a list.
Yeah.
We're building an architecture here.
Okay, let's unpack this then. We're looking at 8 key phases. And to make this feel real, let's imagine we're building something together. Let's say a personalized, smart travel planning agent.
Right.
Yeah, something that doesn't just look up flights, but anticipates your needs, checks your budget, and coordinates everything across multiple platforms. So we start, of course, with that foundational question. What is this thing actually for? So the first step is define purpose and scope. Now, this sounds almost remedial, Let's start at the beginning. But I have seen this fail so many times because teams get distracted by shiny features. Why is defining the problem so crucial to the technical outcome?
It's the single biggest strategic guardrail you can build, the single biggest one. If you don't define the scope with surgical precision, saying our travel agent will book flights and hotels, but not, say, ground transport or restaurant reservations.
Or let's draw a hard line.
Draw a hard line. Otherwise, you invite what's called feature creep, and that instantly complicates every single one of the next steps. If you overscope, you exponentially increase development time, latency, and the eventual operational cost.
So less is more, in a way.
The foundational insight here is that limiting the agent's functionality actually maximizes its efficiency, for its specific job at least.
Okay, so clarity equals cost savings and speed. That makes sense. Once we know the mission, we move to step 2, system prompt design. So we're going from the big strategic goal to the specific instructions that kind of dictate how the agent behaves. But isn't a prompt just telling the model what to do?
It used to be, but it's far more complex now. We're not talking about a single user instruction anymore. The system prompt is the agent's its central identity, its rule book.
It's a constitution.
That's a great way to put it. It contains meta prompts instructions that tell the agent how to think and how to respond. For instance, a part of the prompt might be a guardrail that says you must always cross-reference the cheapest flight with the user's budget before you make a recommendation.
Interesting. So the system prompt isn't just defining the task, it's defining the agent's personality and its safety parameters too.
Exactly. It's where you inject things like chain of thought reasoning, telling the agent to break down a big task like finding a whole travel itinerary into smaller, sequential, verifiable steps. A highly effective prompt acts as a filter for hallucination. It dictates the structure of the output. If your system prompt is weak, your agent will be erratic. It doesn't matter how powerful the LLM is.
Now we have the rules of the road, and here's where it gets really interesting, because now we need to give the agent its reasoning core. That's step 3. Choose the LLM, the large language model.
Right.
This is the brain, the inference engine. What are the key factors here? It's more than just picking the biggest one, right?
Absolutely not. The LLM choice is a balance of really 3 factors: capability, latency, and cost. The model has to align with the agent's needs.
Okay.
So if our travel agent needs to synthesize complex data like find the best flight to London that avoids a 2-hour connection and is under $800, it needs strong, complex reasoning. For that, you might need a large proprietary model, a GPT-4 or a high-tier Claude model.
But those are the expensive ones to run, and they can be slow.
And that's the trade-off. That's the whole game. If our agent was just doing simple categorization, sorting emails or something, we could use a much smaller, faster, maybe an open source model running on our own server.
So the strategy is to match the tool to the job.
Yes. The key insight is that building an efficient agent often means running a smaller, optimized model for, say, 80% of the tasks, and only routing the hardest, most nuanced 20% to those massive, costly models.
Yeah.
It's a strategic choice. Never pay premium prices for basic work.
So the LLM gives it intelligence, but that intelligence is kind of locked inside its training data unless we connect it to the living world. Which brings us to step 4, tools and integrations. This is about giving the LLM access to the real-world APIs, databases, things it wasn't trained on. For our travel agent, this means connecting to live booking engines.
This is the step that transitions the AI from being a static oracle to a dynamic actor. The tools are how the agent actually does things. It performs actions.
So connecting to Expedia's Flight API.
Exactly. Or a weather database,
Ah.
a currency exchange tool. These integrations are what expand the agent's functionality, allowing it to give richer, more current, and, action-oriented responses.
I mean, if we're constantly talking to live APIs, aren't we opening up a massive security and reliability hole? How do you manage that trust boundary between the reasoning brain and, say, a live financial API?
That's a critical challenge. The agent has to operate under extremely tight permission controls. The LLM doesn't just get raw access.
Okay.
It receives a very carefully defined, documented description of the tool's function and its arguments. And crucially, the system prompt has to include logic for input validation and error handling before that API call is even made.
So you build the safety checks in beforehand.
You have to. You have to treat every single external call as a potential failure point. The success of an agent relies on its ability to gracefully handle those external failures and then recover the conversation without confusing the user.
Moving from action to retention, then. If every interaction is just a one-off query, the agent feels transactional. We want our travel agent to remember that I always fly economy unless the trip is over 8 hours.
Or that you prefer a window seat.
Exactly.
Hmm.
That brings us to step 5, memory systems. We're moving past simple tasks into a genuine personalized interaction.
This is where we really separate a sophisticated agent from, glorified chatbot. And memory systems are segmented. You have short-term memory, which is just the conversation history held in the LLM's context window.
Right, which is fast, but it's limited and expensive.
It's expensive to manage, and if the conversation gets too long, that memory just sort of decays or gets forgotten as the context window runs out of space. And that's precisely why we need long-term memory. This typically uses a vector database. So when a user mentions a strong preference, like I hate early morning flights, that piece of information is indexed, vectorized, and then stored in that database.
So the next time I start a conversation,
The agent runs a quick query against the vector store to retrieve the most relevant historical facts about you.
so we're talking about retrieval augmented generation, RG, but it's applied to user history, not a document library.
You've got it. It's RAG for personalization. And this is essential for our travel agent because it lets it build a profile of you over time. The challenge, though, is ensuring that retrieval mechanism is highly accurate.
Because if it pulls up the wrong memory,
If the agent retrieves irrelevant memories, it introduces noise into the context. It leads to bizarre or incorrect results. We call it context contamination. Developers spend a huge amount of time just perfecting the relevance score for memory retrieval.
okay, so we have the blueprint, the powerful brain, and connections with long-term retention. But this whole setup sounds like a high-wire act. It's so complex. How do we make sure the LLM knows when to search the vector database, or when to hit the Expedia API, or when to just answer from its own knowledge? It needs a project manager.
That is precisely where step 6 comes in, orchestration. And what's fascinating here is that orchestration is the traffic controller. It takes the user's request, book me a trip to Paris next month, and it breaks it down into subtasks.
It creates a plan.
It creates a plan and determines the flow. Step 1, check memory for budget and preferred airline. Step 2, query the flight tool. Step 3, if the price is high, ask the user a clarifying question, and so on.
Wait, when you say orchestration, are we talking about running concurrent models and making these dynamic decisions on the fly? That sounds incredibly expensive, especially if the agent calls multiple APIs every time I ask a question.
See, that's why it's non-negotiable. Effective orchestration is actually designed to reduce cost. A well-orchestrated agent won't blindly call the most expensive, powerful LLM for every single step. It manages the data flow, handles the tool selection, and most importantly, it prevents infinite loops.
Infinite loops, like the agent asks for a price, gets a price, and then just asks for the same price again.
Or worse. An agent might decide it needs a certain piece of information, but the tool it calls returns an error. So it tries the same tool again and again and again.
Burning through tokens and API calls.
Exactly, until the system just times out or you burn through your budget. Orchestration provides that crucial step of evaluating the tool's output before deciding what to do next. It ensures progress is made and errors are contained. This coordination makes sure all the parts work together seamlessly and cost-effectively.
Once that internal choreography is flawless, the final hurdles are actually getting that intelligence into the user's hands and then validating the output. So step 7, user interface design. Because all that sophistication is worthless if the user can't easily interact with it.
The UI is the interaction point, and it has to be designed to manage user expectations. If our travel agent needs me to give it dates, the interface should prompt me for those dates clearly. It shouldn't wait for me to guess what it needs.
Right.
Whether it's a chatbot interface or a voice assistant, the design just has to be intuitive and accessible.
I think we all have a horror story of an agent UI that just failed. It didn't give you clear options or it completely forgot the last thing you said.
Precisely. A clunky interface instantly creates friction and distrust. And when the agent can do complex actions, like booking a flight, the UI has to clearly communicate the agent's status. Is it searching? Is it executing a payment? The display has to be precise and match the agent's internal flow for a smooth, trustworthy experience.
And finally, step 8, the ultimate quality control checkpoint before you go live. Testing and ovals. You've built this masterful machine, but you have to prove it works as intended across thousands of different scenarios.
This is where the rigor comes in. So testing ensures the basic functions work. Does the API call actually work? Does the memory system retrieve relevant info? But the evaluations assess performance and usability at a larger scale.
You're looking at the aggregate.
We're looking at the aggregate. How often does the travel agent choose the best available flight? What's the average time to complete a booking? What percentage of queries result in an appropriate, non-hallucinated response?
And testing an LLM-powered system has got to be uniquely challenging because the output is generative. It's not deterministic. You can't just test for one right answer.
That is the core difficulty. You need sophisticated evaluation metrics that are often LLM-based themselves. You might have an external model assessing the quality of your agent's response for things like relevance, coherence, and if it followed the rules in the system prompt.
Wow.
This final step, which is often really resource-intensive, helps identify any areas for improvement before you deploy the agent into production. It's all about quality control and reliability.
It's truly amazing how a seemingly straightforward concept like an AI agent is built on this intricate foundation, where every single step, from the philosophical definition of the problem all the way to the fine-tuning of the performance, is strategically vital.
To summarize, building a truly capable AI agent requires strategic alignment at every level. You define a precise scope, create a robust system prompt, select the LLM based on those trade-offs, integrate tools for action, layer on memory for personalization, meticulously orchestrate the whole system to manage cost and complexity, and then, ensure a user-friendly interface that's backed by continuous, rigorous evaluation. These 8 steps really do move you from just a concept to a functional reality.
This raises an important question for you, the listener. If an AI agent's personalization relies entirely on its memory system, retaining your context and preferences in a vector database, and we are constantly refining that retrieval process to make it smarter, how do developers ensure that personalized data doesn't accidentally leak or get retrieved during an interaction with the wrong user? If personalization is the key to intelligence, what are the technical mechanisms required to enforce strict data separation within these complex memory architectures? Something to mull over as you consider the infrastructure needed to secure the possibilities this detailed roadmap unlocks.